Hello students, so this is a question from JEST 2024 and actually it is based on a second order differential equation, and you can clearly see that these coefficients are not constant. So this is a variable, and such equations in general, if I write, it is P naught x and d2y by dx2 plus P1 x dy by dx and plus P2 x y is equal to 0. So equation is something like this in general. So actually such equations are handled using Sturm-Liouville theory, which is actually based on the problems involving eigenvalues. Okay, the problem involving eigenvalues. For example, if I have some operator L psi is equal to lambda psi, so such problems are handled using Sturm-Liouville theory, and the solutions are self-adjoint in this case. So how you can test that? If this P naught x derivative is equal to P1 x, then the equation, then this polynomial is self-adjoint. Okay, now problem is, if this is not the case, then I can calculate a weight function, which later on can be seen here in this orthogonality relation. So that weight function is like this, that if I multiply it by w L psi, it will become some w lambda psi. And now after multiplying this, our equation will become self-adjoint, and then this will be followed. Okay, so in our case, so what is this weight function? This weight function is given by 1 upon P naught in 1 upon P naught and e to the power integral P1 by P naught dx. This is the weight function which is actually appearing here in this case. Okay, so let us calculate the weight function for this, and now you just compare. For us, P naught x is 1 minus x square, P1 x is minus x. So calculate the weight function. This will be given by 1 upon 1 minus x square e to the power integral P1 is minus x by 1 minus x square dx divided by 2 and multiplied by 2, so that it can be easily integrated. So this will become 1 upon 1 minus x square e to the power 1 by 2 ln 1 minus x square. So this half will come here and it will become under root of 1 minus x square by 1 minus x square, which is 1 upon 1 minus x square to the power minus 1 by 2. So this is the weight function which can be calculated here. So students, those equations which you learn like Legendre, Bessel, Hermite, Laguerre. So for example, in Legendre, that weight function will become 1, and that weight function will be different for these different second order differential equations, which I started you by telling you that those second order differential equation which involves eigenvalue problem. So especially they are very, very important for physics, especially quantum mechanics. Okay, so the reference I will give you, you can see this what I have discussed from Arfkin. So direct question, this question was asked from Arfkin. Actually this is an unsolved problem of Arfkin that I have discussed, and this polynomial, this second order differential equation is actually Chebyshev differential equation. Chebyshev differential equation. So this Cn is Chebyshev polynomial, and this is the orthogonality relation of Chebyshev polynomial when m is not equal to n, otherwise the value is different. Okay, so thank you so much.